Hello everyone. In this video we will see a Wallis formula in definite integration. So this is in equal to integration of sin की power nx dx and the limit is 0 to pi by 2. N is natural number. So the Wallis formula is applicable for the trigonometric function sine. Okay, and the limit is 0 to pi by 2. And one important point is that when we apply the King's formula, this can be also written as 0 to pi by 2 cos की power nx dx. Both the integrations are same. Correct? Number one. So we can apply the Wallis formula when the trigonometric function is sine or cos, power is n is natural number, and the limit is 0 to pi by 2. So here one important result we will develop first, that is in equal to n minus 1 by n into ka in minus 2. This result you have to remember. Okay. Now how? See, I can write out in equal to 0 to pi by 2 sine की power n minus 1 into x and sin x dx. Correct. Now I can evaluate this integration by parts. What is by parts? This is say first function and this is second function because it is integrable very easily. So therefore this is sine की power n minus 1 का x into integration of sin x dx minus derivative of sin की power n minus 1 का x into integration of sin x dx and whole का integration. Correct? This is by part. So here sin x का integration is cos x, so therefore minus sin of n minus 1x into cos x, and when we will put the limit 0 to pi by 2. See, in pi by 2 cos x is 0 and in 0 sin x is 0. So therefore this whole is converted into the 0. Correct? So we are remaining with this one only. So that is equal to minus derivative of sin n minus 1, that is n minus 1 into sin की power n minus 2 का x. Sin x का derivative is cos x and integration of sin x is minus का cos x. Correct? Is that clear? Okay, fine. So from here we can have this minus and minus here plus. So this is n minus 1. Okay, n minus 1 I can take bahar and this is 0 to pi by 2 now. Put the limit 0 to pi by 2. So this is sin की power n minus 2 into cos square x का dx. Correct. So now I can write in equal to n minus 1 0 to pi by 2. This is sin की power n minus 2 का x into cos square x calculator is 1 minus sin square x का dx. So this is what n minus 1 into 0 to pi by 2 sin n minus 2 x dx and then minus n minus 1 into 0 to pi by 2 sin square sin की power nx. Correct? This n minus 2 multiplied sin की power n minus 2x multiplied by sin square x will be sin की power nx dx. Correct? So as you can observe here, this is in, this is n minus 1 into n minus 2 means in minus 2. Correct? And this is minus n minus 1 n sin की power nx 0 to pi by 2. This is in. So finally you are having in is 1 plus n minus 1. This minus will become here plus, and that is equal to n minus 1 into in minus 2. So therefore in equal to n times, no, this is n times. So this is n minus 1 into n minus 2. Therefore in equal to n minus 1 by n into in minus 2. So this is your formula in equal to n minus 1 by n into in minus 2. That is the proof. Now, okay, This is over. We can now remember this, that if in is integration of sin की power nx dx or cos की power nx dx with the limit 0 to pi by 2, that is the Walli's formula. That is Walli's formula. Then we have the result in equal to n minus 1 by n, in minus 2. So they can ask the question, what is the value of I4 by I2? So in minus 2, n equal to what? 4. That is equal to 4 minus 1 by 4. That is equal to 3 by 4. Like that they can ask the question. If in is 0 to pi by 2 sin ki power nx dx, then what is the value of I ki power I4 divided by I2? The ratio they can ask. Correct? Okay. Now, if this is true, then I can also apply for this one. Okay. In is n minus 1 by n. N is here, n minus 1 is here. So therefore for in minus 2, I can write down n minus 3 minus 1 from here. And whatever there, n minus 2 will come here. And this is what in. This is in, then in minus 2, this is in minus 4. Correct? Similarly, now I can write down here as n minus 5 divided by n minus 4. And like that the things will go. Finally, I can write down in, that is 0 to pi by 2 sin ki power nx dx is n minus 1 by n minus 3. Okay, n minus 3 by n minus 2, n minus 5 by n minus 4, and like that. Either I will, the last integration is either I0 or I1. Correct? This will become last either I0 or I1. Now what is I0? See, I0 means integration of sin ki power 0x dx 0 to pi by 2. That is integration of 1 dx 0 to pi by 2. Finally I0 is pi by 2. And what about I1? I1 is 0 to pi by 2 sin x dx, that is minus cos x 0 to pi by 2, and that will become 1. Correct? Finally, you can see that the last term is either 1 or pi by 2 in multiplication. Now therefore I can write this as a in equal to 0 to pi by 2. Now see, very interesting, dx, very interesting. This is n minus 1 into n minus 3. So first I have reduced n by 1. Then I am starting reducing by 2. So this is n minus 5, and like that. Correct? And here this n comes. Then now starting reducing by 2, n minus 4. And here I can write down k, where k is either pi by 2, k is pi by 2, or k is 1. K is pi by 2 when n is even. N is even. And k is 1 when n is odd. Correct? K is pi by 2 when n is even. And k is 1 when n is odd. Why odd? Odd no. When suppose this is, say at this time 5. N is 5 means 5 minus 4, that is I1. I1 is 1. Correct? And n is 6, then 6 minus 4, that is I2. Then I2 is there. Then 6 minus 4 minus 4. Suppose 4 minus 4. That will be I0. Correct? When n is 4, then 4 minus 4, that is I0. That is equal to pi by 2. Correct? So therefore this k is either pi by 2 or k is equal to 1 when n is even. Okay? K is equal to 1 when n is odd. You have to remember. Now but important point is that, what is this? This is very easy to remember. For this, you have to know the double factorial. Now look at here, double factorial. Double factorial. This is 10 ka double factorial. It is 10 into 8 into 6 into 4 into 2. Or 9 ka double factorial is 9 into 7 into 5 into 3 into 1. This is the way double factorial written down, correct? So 10, 10, then reduce 2, then reduce 2, then reduce 2 and keep going on. Reduce 2, like that. So therefore this n minus 1 is the first one, then we are reducing by 2. Therefore this is n minus 1 ka double factorial. You can easily now remember this formula, that is equal to n minus 1 ka double factorial. And similarly here n, then we are reducing to n ka double factorial into ka k. So this is easy to remember. N minus 1 ka double factorial divided by n ka double factorial into k, where k is either pi by 2 or k is equal to 1 when n is odd and n is even. So now you can easily remember this Wallis formula. In a equal to integration of sin ki power nx dx or cos ki power nx dx when the limit is always 0 to pi by 2 is n minus 1 ka double factorial. What is n there? Then subtract 1, take its double factorial. What is n there? Here n double factorial into k. K equal to pi by 2 when n is even, k equal to 1 when n is odd. I think that now easily we can apply this formula. Finally we can apply this formula. We can remember this formula. This way difficult to remember, but this is very easy to remember, provided you should know how to write down the double factorial, correct? So therefore first problem, if I want to find out sin ki power 11x dx 0 to pi by 2, 0 to pi by 2 limit is there for Wallis formula for sin function and cos function, correct? So this is what 11 minus 1 ka double factorial divided by 11 ka double factorial, correct, into ka k. K is depending upon this odd or even. This is odd, therefore k is equal to 1 here. So finally you are having 11 minus 1 means what? 10 into 8 into 6 into 4 into 2. This is what 11 ka double factorial. 11 into 9 into 7 into 5 into 3 into 1. That is your answer. This is your answer. Very easy. Correct? Second, if I want to find out 0 to pi by 2 sine of 10x dx. Rather we will take cos of 10x dx. Okay. Cos x dx. So this is what 10 minus 1 ka double factorial by 10 ka double factorial into ka k. K is here pi by 2. Why pi by 2? Because this time n is even. For even, k is pi by 2. Okay. So therefore this is simply now 9 into 7 double factorial to 2 we will reduce 5, 3 into 1 here 10 into double factorial 8, 6, 4 into 2 and of course this pi by 2. This is your answer, correct? Now this is the basic, okay, how to apply the Wallis formula, but they can ask the questions by using some other concept of a definite integration as well. For example, if I say that find out the integration of minus 2 pi to 2 pi of cos की power 6x dx. How to do that? Okay, cos की power 6x. Therefore, I can apply the Wallis formula if the limit is 0 to pi by 2. But 0 to pi by 2 is we are not observing. So, we can apply the other concept. This is what? This is even function. So, even function property from minus a to a can be written as 0 to 2 pi cos की power 6x dx. Again, I cannot apply the Wallis formula now because it is 0 to 2 pi, not 0 to pi by 2. So, pi by 2 how to convert? So, now this is periodic with period pi, that you have to remember. This is 2 pi. So that periodic property I can apply. So this can be 2 into 2 into 0 to pi cos की power 6x dx. Still it is not pi by 2, it is pi. But this pi can be written as 2 into pi by 2. And here we can apply that f of 2a minus x is equal to f of x, then integration of fx dx from that 0 to this is 2a can be written as 2 to 0 to a fx dx. This property I can apply over here. Correct? Why? This is pi is 2a. Cos of pi minus x. Cos of pi minus x is minus cos x. But as it is coming into the second quadrant, this is negative. But the power is even. Therefore, that negative is vanished. And therefore, this is simply cos की power 6x. Means cos of pi minus x की power 6 is equal to the, that is cos की power pi minus x and इसकी power 6 is equal to cos की power 6x. So finally again we can apply this property, and this is 2 into 2 into 2. This is now 0 to pi by 2. Now you can apply directly the Walli's formula. What is that? This is 8 into cos की power 6. So 6 minus 1 का factorial, double factorial, 5 double factorial, 6 double factorial into का k. K is pi by 2, n is even. So this is pi by 2. So this is 8 into 5 factorial means 5 double factorial, na? 3 into 1 and 6 means 6 into 4 into 2 and then pi by 2. This is your answer. Correct? So this is a very nice problem. You cannot apply the Walli's formula directly, but you can convert this to apply the Walli's formula by using the other concepts. For example, this minus 2 pi to 2 pi cos की power 6x. This is even function. So even function definite integration property I can apply 2 to 0 to 2 pi. Then this is periodic function with period pi. Then periodic property of definite integration I can apply. Then again I can apply the integration of fx dx when limit is 0 to 2a and f of 2a minus x is fx, then it is 2 times 0 to a fx dx. So this is Walli's formula. Second Walli's formula is also there. I am telling you that formula as well. Now directly you can apply that. Which is that? This in equal to 0 to pi by 2 sin की पावर nx into cos की पावर n की जगह m कर देते हैं mx, and this is nx dx. M and n are both are natural numbers. Correct? So this can be written as, what is that? m minus 1 का double factorial into n minus 1 का double factorial upon m plus n का double factorial into का k, where k is pi by 2 and k is 1. What is when k is pi by 2? When both m and n are even. Otherwise, when both are odd or one of them is odd, then k value is 1, and if both are even, then k value is pi by 2. M minus 1 ka double factorial, you know that m minus 1, then reducing to m minus 3, then reducing to m minus 5, and like that. Correct? 1 or 2 we will stay there like that. N minus 1 into n minus 3 into n minus 5 like that, divided by m plus n into m plus n minus 2, m plus n minus 4 like that, n into k. So it is horrible. It looks very horrible. This formula looks very horrible, very difficult to remember. But when you apply the concept of double factorial, it is very new. But double factorial, you can m minus 1 का double factorial, n minus 1 का double factorial, m plus n का double factorial into का k, where k is pi by 2. When both m and n are even, or k is equal to 1. Otherwise means when one of them is even or both of them are odd, then k equal to 1. Only k equal to pi by 2 when both m and n are even. Then double factorial, how to represent, you should remember. Let's do the problem. Okay, let's suppose that this is 8 and this is 6. So therefore it is what? 8 minus 1 ka double factorial into 6 minus 1 ka double factorial into 8 plus 6 ka double factorial into ka k is pi by 2 here, correct, because both are even. So therefore 8 minus 1 means 7 ka double factorial, 7 into 5 into 3 into 1. Okay, then 6 minus 1 means 5 ka double factorial, 5 into 3 into 1. 8 plus 6 means 14, 14 ka double factorial, 14 into 12 into 10 into 8 into 6 into 4 into 2 into ka pi by 2. That is your answer. So in that way we can apply the Walli's formula. Also, if suppose that some algebraic terms are there and the limit is 0 to 1, this is suppose x ki power 7, 1 minus x ki power say 5, like that. So this problem 0 to 1, but that can be converted into the sine function and cos function, and we can apply the Wallis formula by putting x equal to sine square theta. So 1 minus sine square theta will be cos square theta, that will give the cos ki power. X is already sine square theta, that will give the sine ki power, and dx will be 2 sine theta cos theta. Finally, you converted this expression in terms of power of sine into cos ki some power, correct? And now the limit when x is 0, this is theta is 0, okay, the theta when x is 0, theta is 0, but when x is 1, then this is 1. So therefore theta is what? Sin theta is 1. Sin theta is 1 means theta is pi by 2. And finally you converted into the 0 to pi by 2 sin ki some power into cos ki some power, and therefore you can apply the Wallis formula, correct?